Hello there. This video is on AP Calculus BC 2024 solutions FRQ number 5. It's based on Maclaurin series and a couple of radius of curvature, etc. So let's read this one out. All right, so the first question which we have is the Maclaurin series for the function is given by this and converges to fx for all x in the interval of the convergence. Can be shown that the Maclaurin series for f has a radius of convergence of 6. Determine whether the Maclaurin series for f converges or diverges at 6. Give reason for your answer. So let's find f of 6. The f of 6 is going to be summation of n from 1 to infinity, n plus 1, and x is replaced with 6, so that's 6 raised to n over n squared times 6 raised to n. So 6 raised to n is gone, and I'm left with summation of n equal to 1 to infinity of n plus 1 over n squared. I need to use a test to determine whether this is convergent or divergent. I think I'm going to use a direct comparison test where the series which I need to find or determine is n plus 1 over n squared, and the series with which I'm going to compare it is n over n squared. It makes sense that n over n square versus n plus 1 over n square. Which one is a bigger series? Obviously, an is a bigger series. So I'm going to say bn is less than an or an is greater than bn, which means that n over n square is less than n plus 1 over n square. N over n square can be written as 1 over n. So 1 over is less than 1 over n square. And now I'm going to put a sigma so that both represent series now rather than sequence. This is how it looks like. Now guys, what do you think about 1 over n? What kind of series is that? Either you can say that this is a harmonic series and harmonic series are always divergent in nature, or you can say that this is a p-series test with p-series with p equal to 1, and that way is also that is divergent in nature. So either you can say this is a harmonic or with p series with p equal to 1. Either way, this is divergent in nature, and since the bn is divergent in nature, it concludes that an must be divergent in nature because of the direct comparison test. So this is what we have as the answer to part A. Part B talks about it can be shown that f of negative 3 is 3. F of negative 3 is this, which can be simplified with this, and that the first three terms of the series sum is this. We have to show that f of minus 3 minus s3 is less than 1 over 50 in absolute values. Don't you think that they are talking about the error? Because we know that fx is nothing but the sum of this series. It converges to fx, right? So we have f of x as the actual sum, s3 as the partial sum, and absolute value of the difference denotes the error, right? So this is the error, and mind it, this is an alternating series because it's negative 3 raised to n, so it will switch from plus minus and plus minus. And we know that in alternating series test, in alternating series, if we want to determine the error, then the absolute value of error is always less than the immediate next term. And the immediate next term is obviously, since they are finding the sum of 3 terms, the immediate next term is 4. We already have the simplified version of a sub n expression. So let's write this separately over here, that a sub n is n plus 1 over n squared negative 1 over 2 raised to n. So all we need to do is plug in 4 over here. So that's going to look like 4 plus 1 over 4 squared negative 1 over 2 raised to 4. So that's going to look like 5 over 16, and this is also 1 over 16, and 16 times 16 is 256. But I need to determine whether this is less than 1 over 50 or not, which obviously I do not have that expression right now. But this can be easily manipulated, right? If you want to realize that, and by the way, this is no calc, so yeah, that's not allowed. What we can do is, notice 1 over 50. Can I multiply by 5 and divide by 5 here? That's allowed, right? Mathematically, I can multiply by 5 and divide by 5. So this is 5 over 250, as good as 5 over 250. And guys, if you can tell me, how will you compare 5 over 256 and 5 over 250? Obviously, 250 is the one with the denominator, smaller denominator is going to be a bigger number, right? So can I say that 5 over 256 is less than 5 over 250? We just agreed on this, right? Less denominator means a greater fraction. So that's what I'm saying, that this is greater than this. And by the way, this is greater than what? Do you think this is greater than the error? So can I write error is less than 5 over 256 is less than 5 over 250? So doesn't that conclude that the error is less than 5 over 250? And what is 5 over 250? That's just 1 over 50, which we were supposed to prove. So in this way, you can use the alternating series error bound formula and then compare it eventually with 5 over 150 by a simple manipulation, and that will now make absolute sense. I hope this one is clear. The next one is talking about find the general term of the Maclaurin of f prime and then the radius of convergence of f prime. So that's pretty straightforward. All we have to do is just take the derivative. So f is given as sigma of, I'm not writing the bounds, I think that's understood. So n square 6 raised to n. So f prime is going to be, sigma remains as it is, n family is untouched because the derivative is of x, and this x is just gone. It's n x n minus 1. One of the n can be cancelled, and finally f prime is n from 1 to infinity n plus 1 times x raised to n minus 1 over n times 6 raised to n. That is the general expression, or the term, general expression for the term, or for the series of the f prime. And now they want us to find the radius of convergence of the Maclaurin series. So for the radius of convergence, all you have to do is just take the ratio of the immediate to the preceding term. So a n plus 1 over a sub n. That's what you have to do. And you have to set the limit of this thing to infinity of the absolute value. Let's do that. This entire thing is actually our a sub n. So this becomes limit n approaching infinity of, let's replace every n with n plus 1. So n plus 1 over here when replaced will become n plus 2. This n plus 1 will become n plus 1 minus 1 because there is a minus 1 here. So that becomes n. This is n plus 1 and this is 6 raised to n plus 1, right? This is to be divided by, well, obviously I'm going to use KCF in a minute, but let me just first write this gross expression. This is how we have. Let me actually, make this a little longer so that we understand. Okay, I think I'm gonna need more space, but for the time being, I'm just gonna KCF over on this side. So if I use keep change flip rule, I'm going to keep this one, and when this is flipped, then this thing will come on the top. So this will become n times 6 raised to n, and the other things are in the denominator, which is n plus 1 times 6 raised to n plus 1 times n plus 1, and I'm running short of space. So hang on. Right, I just made some space. So 6 raised to n plus 1, and then n plus 1 times x raised to n minus 1, and this absolute value is closed over here. Okay, I'm gonna erase this portion. Now it's gonna look further as limit n approaching infinity. A little bit of redecoration is required. N plus 2 is as it is, x raised to n is as it is, n is as it is, 6 raised to n is as it is. However, here this 6n plus 1, 6 raised to n plus 1 can be written as 6 raised to n times 6. and this n plus 1 still remains as it is, and x raised to n minus 1 can be written as x raised to n times x raised to minus 1. What is the benefit? Benefit is these two are gone, these two are gone. Anything else? No, unfortunately not. So, okay, let's write another terms. The next term, limit n approaching infinity. This x raised to minus 1 just moves over on the top. So, it becomes n times n plus 2 times x over n plus 1 whole square times 6. Now, if you notice carefully, when we are putting a limit n approaching infinity, don't you think this is the ratio of two polynomials having the same degree? Because here also the degree is 2. Okay, if you do not understand like this, I can definitely write another step for you to make it more clear. Can I write this as n square plus 2n? X remains as it is. Can I write n plus 1 whole square as n square plus 2n plus 1? 6 remains as it is. And now if you see, this is a ratio of two quadratics having the leading coefficient of both as 1. And if you remember, this is a little bit of maybe pre-calculus, that whenever this happens, then the ratio of the leading coefficient is basically the answer of the limit. So the leading coefficient of first one is 1, x remains as it is. The other one is 1, 6 remains as it is. And that now is supposed to be less than 1 if we want to find the interval of convergence. So this means that absolute value of x is less than 6, which means that the interval of convergence, not that they have asked, but is this, and the radius of convergence is just going to be this. Obviously here we need to check the 6 and minus 6, so let me just skip writing it because I'm not sure about the terminal points. But yeah, the radius of convergence is definitely 6 over here, which is what they needed. And finally, the last one says that this is gx, and we have to use the ratio test to find again the radius of convergence. So the radius of convergence once again is going to be limit n approaching infinity of a sub n plus 1 over a n. That's what we need to find. So limit n approaching infinity of every n is replaced with n plus 1. So this becomes n plus 2, x raised to 2 times n plus 1, n plus 1, n plus 1. And we divide this with a sub n. So again, I'm going to use the same thing. So keep change flip. So when I flip this up, the n square and 3 raised to n comes on top, and n plus 1 times x raised to 2n stays at the bottom. Okay, do we have, okay, I think we need to decorate this a little bit for things to cross out. So n plus 2 is as it is. X raised to 2 times n plus 1 is nothing but 2n plus 2, and x raised to 2n plus 2 is x raised to 2n times x square. N square is as it is, 3 raised to n is as it is. Likewise, this is n plus 1 whole square. 3 raised to n plus 1 is 3 raised to n times 3. This is n plus 1, and this is x raised to 2n. Okay. This is gone. This is also gone. So what are we left with? We are left with limit n approaching infinity of n square times n plus 2. That's the first expression on the top. X square is the remaining thing. And over here, this is n plus 1 whole cube and 3 as it is. And don't you think this is the exact same thing that we have a polynomial, cubic polynomial on the top, cubic polynomial at the bottom, limit is approaching infinity. So the answer is the ratio of the leading coefficients. So I'm going to need a little more space here. So let me go over here. Okay. So this one is, like I said, this is 1. So limit n, okay, by the way, we have to already place the limit. So x square over 3 is less than 1 now in order to find the interval of convergence and the radius. So x square is less than, absolute value of x square is less than 3. Absolute value doesn't really play any role because that's already squared. So x square is less than 3, which means that the radius of convergence, although the tentative interval of convergence could be this, although keep in mind that these points I have not tested yet. Anyway, that is not been even asked. What we are interested in the radius of convergence, which is surely square root of 3. So I'm just going to erase this expression, erase this inequality from here, and I'm just going to conclude that This is what I have. I mean, the other inequality, if you want, which I can add, is absolute value of x is less than root 3, which now matches with, you know, the usually the expression which we see for radius of convergence. So this should be our answer for this one. I hope this makes sense. Any questions, please post it in the comment section, and I'll see you in the next video. Bye-bye.